All right, ladies and gentlemen, we're going to compare Fischer esterification, which we did earlier today. And we'll do 3 steps. We'll do red first, blue second, and I think we can save a little bit of time by erase this H, stick it off here. As the first step is to activate the carbonyl with the strong acid. Second step is to attack the carbonyl that you activated. And the third step would be the sulfate ion that you just generated. HO3 SO minus. And we'll go with green. Neutralizes your oxonium. And you are at this stage right now. Go with the blue here. Oh, black. Stage right here. Got an O. It's got an H on it from the catalyst. Got the old OH. Got a methoxy. And it's time to get rid of the water, isn't it? You need the catalyst acid for protonating the leaving group in the first step. You need the base. Since the leaving group is nice, you don't need much of a base. And this, oh, no, it can't be red though. Gotta be blue. And that's home free right there. And next up is diazomethane. Diazomethane is an interesting molecule. It's got 2 resonance forms. I would have to say of the 2 resonance forms, I'm liking the second one better, where there's double bond to N, double bond to C with 2 H's. And why do you think I like the black one better? Well, they're both black. This new one better than the old one. Carbon is less stable as an anion than nitrogen because of hybridization. Not hybridization, what am I talking about? Electronegativity. N pulls this pair of electrons that's the minus closer to the nucleus than C. And you could use the hybridization argument. It's not a bad one. sp2 brings the anion closer to the nucleus than sp3 over here. That's another argument, but the electronegativity is the big one. But I like this resonance form over here because it really helps me with my mechanism. So all I'm going to do is just recopy the carboxylic acid because I already had it doing other things up there. And down here, the things are very different. And I'm also going to copy the first version of this because you can use either resonance form in a mechanism, even if one of them is not as good as the other. And tell me what kind of reaction this is. That is not a surprising new reaction. That goes back to chapter 4, everybody. An O minus is grabbing what particular ion? Oh, bad spot. What particular ion is the O minus attacking? It's called a proton, everybody. And there's a real methyl group attached to an I don't even want to say it. It's going to go away. But what kind of things go away? Leaving group. And what category of leaving group is it? Yeah, exceptional. It's a gas. So I don't care what kind of a nucleophile this is. It's moderate, but any nucleophile is going to do this. Backside attack, leaving group leave, home free. This was an easy mechanism, wasn't it? I only lost a half point too. Somebody's going to tell me where I lost my half point so I can get it back. I said I copied this, and then I said I copied this, but I didn't really copy that. I was careless. Yeah, the minus charge I didn't copy. Oh, there. I got my half point back. You could write that an advantage is a much shorter mechanism for the bottom one, but I'm not looking for that. I'm talking chemistry. Fischer reaction, let me just tell you, it's a slow reaction. It can take days. I'm not joking. Many of them take days or weeks to finish with a good yield. You have to wait that long for the condensation process and the Dean Stark trap, if you got one, to remove the water. So that's a disadvantage there. The advantage down here, this one's done in seconds. 1, faster. 2, the side product's a gas. Do you have to bother purifying that away from the ester, which is still in solution? No. So easier cleanup, I guess is what you would say. But in lab, we don't say that. We say easier work up. Work up's when you get rid of all the side products and things and clean up before you're about to do either a purification or move on to the next step if you deem that this is pure enough already, which it usually is. After the diazomethane esterification, you'll probably just be adding your next reaction on top of that without purifying further. And advantages here. Let me just talk to you about diazomethane. Diazomethane must be used immediately after you make it. It doesn't store at all. You can't have a bottle of it in the back room. There's a recipe you got to follow to make diazomethane, and then as soon as you make it, you add your carboxylic acid to it. So that's a disadvantage, right? So make it into an advantage up there. Chemicals are more stable. For this top one, everything's got bottles of everything in the back room for that one. So chemicals are more stable, so it's safer and easier in that way. More shelf stable. And 2, this is the cheapest way you're ever going to go. Methanol is 10 times cheaper than diazomethane. That's a huge unexaggeration, 100 times cheaper. Okay. So there you go. I think it's good activity.